Okay, so let's take a look at forces question. So what are the two types of forces? Just a bit of a recap. P6 forces. Images. What are two types of forces? Wow. See, it's over here. Push and pull. Okay? Push and pull. So you only learn about push and pull in forces. Right? Forces, push and pull. So it's really not too difficult, right? So most of the questions are all about push and pull. We also learn about gravitational force, correct? Frictional force, very good. Some are contact. That means the friction is a contact force. This gravity is a non-contact force. It's not in contact. Alright, so let's look at 49 forces. So we have this experiment. So Charles noticed that more force is required to move the wooden block across A than B. Why? Why?
It's smoother.
Yeah, which one is smoother?
A.
B?
Oh, B.
Yeah. So you can say that ram A, or the surface of ram A has more friction, right? Has more friction, hence it takes more force to overcome the friction. Well done. Okay, so state how the pulling force changes with angle x. As x increases, what's going to happen to the force? Is it more or less? Okay, what happens when x changes? That means it becomes steeper. Yeah, correct. So we say that as x increases, angle x, it will take more force to pull the block. The slope. Okay, that's it. It's pretty straightforward stuff. Next. Is it okay? Can Next. Okay, swing. Which object is definitely a magnet? Okay, so magnetic force is also a force, correct? So which one is harder? Which object is definitely a magnet? Now, how do you test whether something is a magnet? What's the most conclusive test? There's only one way to confirm something is a magnet. What's that? It must repel. Do you remember?
No.
No? Okay. If it attracts, right, does it mean that it's a magnet? No, because it can be a piece of metal. But only magnets repel. Okay? You can remember this one. Only magnets repel. So which one shows it repelling? So you see the length of spring when switch was open is 10. Then this one is 8. That means it's okay, let's take a look. So this is the length of the spring. You put the iron nail here. So this object actually extended. If it extends, that means it attracts. It's 14 extension, so it's attract. But if it's 8, what does it mean? It went backwards, no? Went backwards, right? So it's a repel. So A is a magnet. Oops. Okay. A is definitely a magnet. So object A is a magnet. So why? Because it repels when the iron nail was magnetized, and only magnets will repel. Okay, so that's the key idea. Only magnets repel. So what can you conclude about the property of material used to make object C? Object C was attracted. So what type of material is it?
Iron.
Yes, that's one name of the material, but you gotta talk about the property of the material. It's a metal, right? And hence, what's the property of metal? Heat. Heat. Metal. What's so special about metal? Can it conduct electricity? Yeah, it can conduct electricity. Is it attracted? Ooh. Can conduct electricity. And what else? What's so special about magnets? Well, not magnet, metals. Can conduct electricity. Let's talk about the melting point. Sorry?
Heat.
Yeah, and heat. ECD. Okay, it also has high melting point, high boiling point. Right?
This question, like, you must find the length. Like it'll be something like that. Then you weigh, like, you see how long.
That's the extension.
Then you must find the original length.
Yes, correct. That is the extent. We are going to see this, right? The question that I talk about is somewhere inside. Okay, so we're going to see examples of that. Where is it? Let me see. Confirm have. The what? Extension. No. Somewhere at the back. That extension one, right? I know that's a common type of question to go through. Okay, we will get there by today. I think so. Okay, so we are now at this one. So Hafiz want to find out if the area of plastic sheet affect the time. So based on information, what could Hafiz conclude? You see, the bigger the plastic sheet, the longer time it takes to reach the ground. Okay, so we just say that the bigger the area of the plastic sheet, the longer it takes for the toy soldier to reach the ground. Right? How Hafiz will find out if the mass of the toy will affect the time taken? So what can he do? Now he wants to find out if the mass will affect the time taken. Does the mass affect the time taken? What can you do? Change something, right?
Change keep the plastic sheet.
Yeah, very good, right? So keep the area of the plastic sheet the same, but conduct the experiment with different masses of the toy soldier, right? Okay, so just conduct it several times. Okay, do a couple of times. Great. Next. Okay, explain how this setup enables the camera to take the photograph of an animal. Okay, so this is a very interesting setup where the animal is supposed to land on the bowl, right? So they try to trick the animal with some food. Okay, they put some food here. So the animal comes and will stand on this thing, right? When it stands on this thing, what happens? There's weight, so it will compress, spring will compress, and then what happens here? This is a closed circuit. Okay, XY will come into contact with each other, closer circuit, and the camera will take a snapshot. Okay, so what do you write here? Exactly what I said, right? So when animal lands on the bowl, the spring will compress, causing X and Y to come into contact and closes the circuit for the camera to take a shot. That's it. Right? So everything explained in one sentence. One mega sentence. Just wait for you to copy. Can see or not? Is it glaring? No, huh? Just put it like that. So apparently the animals are cleverer than him, right? What did the animals do? The small ones, they were able to eat the food. Okay, according to the second part. Oh, it's haven't finished. Finish first. Right. So apparently the small animals are smarter than him. They were able to eat the food without him knowing. Right? So what's the reason for that? It's because the spring is too hard. So the small animals, when they land on the bowl, it doesn't cause the spring to compress. So what's one change? Sorry?
Because it's light, right?
It's too light. So what can you do?
Record the whole thing.
Record the whole thing? No,
So
no, no,
they
no,
would
no.
just-
No, I still want to get the animal, you know, when it's the small one. So what I can do is I can change the spring. So change the spring so that it is easier to compress, right? So you just change the spring to something that's not so hard. So that you can capture the animal, small ones. Next. Okay, so we have two electromagnets. So how can you tell the strength of both is the same? Right? What's the first thing we check? We check the number of paper clips, right? The number of paper clips. Okay, so how many paper clips are each on the iron core and the steel core? 4, right? So there are 4. They are the same number of paper clips attracted to the electromagnet from the same distance. Okay, so there are two things you gotta talk about. It is the same number of paper clip plus the same distance. Is that okay? Same number of paper clips and at the same distance. So, Alan switched off the thing, right? And then you realize something interesting. The paper clips fell from the iron but did not fall from the steel. So, why is iron used rather than steel in a recycling plant? You know what's a recycling plant? Recycling plant is they need to take this metal to go and melt it so that the metal can be used for something else. So in this recycling plant, what they do is okay, let's take a look, right? Let's see if we have a recycling plant. Picture of a recycling plant. Oops. Okay, recycling plant. Recycling plant. Huh? What's going on? Okay, wait. Okay. Recycling plant. Okay, see this? Recycling plant. Alright, let's look at the picture. So this is a recycling plant. What it's doing is it needs to pick up the metal and put it at somewhere else.
Is it like the place in Toy Story 3?
Yeah. So it needs to be an electromagnet, to pick them up and then throw them somewhere else, right? You see this? Right? The electromagnet will pick this up, then put at the conveyor belt, pick up, put at the conveyor belt. Okay, so the question is asking which type of metal should you use? Should you use the iron core one or the steel one? Now you have to take note, the steel one, what happened? The steel one never let go, but the iron core one let go. So which one do you use?
Iron.
Yeah, use the iron one, that's right. Okay, so iron. Oops. Iron, right? We use the. Also, they already said we use the iron. Why? So that the.
Let go.
Yeah, you can let go of the metal plate, right? So that the metal parts can be removed to another location without sticking to the electromagnet, right? So you don't want it to be stuck there, right? Okay, if it's stuck there, how can it be used?
Tested this in the before.
What?
You tested this before.
Sorry, eventually will it fall?
You tested this before.
Who?
Make the question.
This one?
Papers.
You have seen it before, yeah. Right, so it's a bit of a you need to know like what's a recycling plant, what they do in the recycling plant, or you could have watched Toy Story. Then you know what's going on, right? If you didn't watch Toy Story or you have no idea what's a recycling plant, then you cannot do lah. Okay, so he used a sensor to measure the strength, repeat the experiment with 50. So it's further away, right? So reading on the sensor. Okay, so the distance of the sensor from the electromagnet affected the reading, right? The further it is, the smaller the readings. It is far away from the electromagnet, it's very near the electromagnet. So when it is further away, you see the reading is lesser. So how did the distance affect the reading? The further away, the lesser reading, right? Because this a magnet works in this way. The further it is, the less magnetic force there is. Next. So what can Alan do to increase the strength of the magnet? This is an electromagnet, right? You want to increase the strength, what can you do? This is Alan, right? Yeah, you want to increase the strength. Yep. Increase the number of coils. Okay, actually what else can you do? Add more batteries. Yeah, make it more powerful. Right, this is like Alan. So this is Alan when he's old, see? When he was young, he was playing with this. So when he grew old, he became like that. Working in an recycling.
Imagine if his name is actually Alan.
Yeah, could be, You see, Alamy, alamy.com. Somehow, quite. Maybe it's Alan. Businessman watching plastic cans. Okay, so Tom noticed that the school attendant always puts a sign. Why someone could sit and fall when the floor is wet?
Because water reduces friction.
Very good. Right, so this is an explain question. So we say that water reduces friction that may cause a person to fall when he walks the surface. Right, so water reduces friction. It's a lubricant. You can also mention that it's a lubricant. It's a keyword. By now, can you see that this is a common thing? Oops. Right, very common. You elevate the thing. What's going to happen is that the higher the angle, can you see that? The higher the angle, the easier it is for the wooden block to slide down. Okay, this thing incline, then this thing will slide down. Okay, so we see some data over here. So this is the angle at which it starts to slide down. So for anti-slip mat S, which one is the best? It's T, right? Because T can go up to 65 degrees. Okay, 65 degrees. So the question is, which is the best? The best was T. Explain.
It's higher.
Yeah, it can incline the highest before the wooden block slip down, which means that it has the highest friction on its surface, right? Friction, highest amount of friction. So put a tick for the rubber dash, he should keep the same. Right? So we're going to tick on the size, right? Size must be the same. Okay. Alright, great. So the size must be the same, yes. Surface, yes. Angle, cannot. Starting position, yes. Right, so 3 except for the last one. Okay, so we still got more to go, but it's time for a short break. Right, 5-minute short break. We're gonna come back again. We're gonna go catch Pokemon.